Hi, this is Group 2. We'll talk about the limits of transcendental functions, which include the
So for today's discussion, we will be focusing on the limits of transcendental functions, which include exponential, logarithmic, and trigonometric functions. But before anything else, what is transcendental function? Okay, so transcendental function is a function which is not an algebraic function. So in other words, a function which transcends or cannot be expressed in terms of algebra. So now let's move on to formula. So as what I've stated earlier, there are three types of transcendental function. We have exponential, logarithmic, and trigonometric functions. So the first one will be the limits of exponential function. So this will be the formula for the limits of exponential function. So for any a, which is element of real number, the limit of e raised to x as x approaches a is just equal to e raised to a. And if b is greater than 0 and b is not equal to 1, then the limit of b of x as x approaches a is also equal to b raised to a. So this means that we can just do direct substitution as long as the conditions here are satisfied. So now let's move on to the formula of the limits of logarithmic function. So how do we read this? Let b be greater than 0 such that b is not equal to 1, then the limit of the logarithm of x base b as x approaches a is equal to the logarithm of a base b, provided that a is greater than 0. So again, just like in the formula of limits of exponential function, we will just do again the direct substitution, and you will still be following the different laws or rules that we do in evaluating logarithmic expressions. The limits of trigonometric function. So here, we will just let a be contained in the domain of the function whose limit is being evaluated. So, for example, this one, the limit of sine of x as x approaches a is equal to sine a. And also the limit of cosine x as x approaches a is equal to cosine a. And the limit of tangent x as x approaches a is equal to tangent a. And the limit of cotangent x as x approaches a is equal to cotangent a. And the limit of cosecant x as x approaches a is equal to cosecant a. And last, the limit of secant x as x approaches a is equal to secant a. So just like what I've said, we will just let a be contained in the domain of the function whose limits is being evaluated. So I'm gonna show you the unit circle because later on we will be using this one. So now let's move on to the examples. So here in example number 1, limit of sine x as x approaches pi over 6. So in the given number 1, we will just be going to substitute the value of x by pi over 6. So if we're going to look at the unit circle, pi over 6, that will be equal to square root of 3 and square root of 3 over 2 and 1/2. And we knew that sine is the y coordinate value, which is why we get here, which is why we get 1/2. And for the example number 2, again substitute the value of x by pi over 4. So now let's multiply 2 and pi. And that would give us 2 pi over 4. And then we can be simplified. So when we simplify this, this will give us pi over 2. And now we're going to look at the unit circle. The coordinates of pi over 2 is equal to 0 over 1. And that is 90 degrees Celsius. So we knew the tangent is equal to sine over cos, right? And remember that the y value is the sine and the x value is the cos. So we divide 1 over 2 and that would give us 1. For the example number 3, let's identify the limit of logarithm of x base 2 as x approaches 4. So since this is a logarithmic function, we can perform the direct distribution, and that will give us logarithm of 4 base 2. Remember that in logarithm, we are identifying what exponent are we going to use to the base so that we will arrive at the argument, which in the case is 4, so the answer here should be 2. For the example number 4, let's identify the limit of 4 times 2 raised to x plus 5 as x approaches to negative 2. This is an exponential function, so again, perform direct substitution, and that is 4 times 2 raised to negative 2 plus 5, and then simplify, and that will give us 4 times 2 raised to 3. Again, simplify the 2 raised to 3, that will give us 8, multiply 4 by 8, and the answer is 32. For this example number 5, it is obvious that this is an exponential function. So in this case, we can actually solve it by simply looking at the given question. So it's as simple as that. Simplify the value of x, and that will give us 60. Example number 6. Let's identify the limit of sine pi x over 6 as x approaches 6. Same with the previous examples, we can just substitute the value of x, which is 6. We now get sine pi times 6 over 6. Then, we can just cancel 6 over 6. That will give us sine pi. By looking at the unit circle, we know that sine pi is equals to 0. That would be our answer. So this one is a logarithmic function. And as you notice, we have here ln. If you see ln in a given question, that means we are having natural logarithm. And when we come up with natural logarithm, that means that the base is e. But still, we will be applying the same process of what we did on ordinary logarithmic functions. So here we substitute and we get ln of 3, substitute the x by 3 minus 5. So this is now equal to 9, ln of 9 minus 5, that is equal to 4. And the next step is to get the ln of 4. So remember, ln the base e. So we have to think of a number that will uses the exponent of e so that the number is 4. And that will be equal to 2. Example number 8. Let us evaluate the limit of logarithm of 3x squared plus 54 with base x as x approaches to 3. You can do a direct substitution here. Change the x to its value, which is 3. Now, we solved everything inside the parentheses. 3 squared is 9, multiplied by 3 is 27, and added to 54 is 81. We then identify what is the exponent of 3 that would come up to the argument, which is 81. When we have 3 to the 4th power, we get 81. So, the answer would be 4. Now, let's try this one. First, again, substitute. So we have logarithm of negative 2 plus 5 minus 2. So we will simplify, and that will give us logarithm of 9 minus 2. So solve for 2 logarithmic 9 base 3 first. And you will get 3. Now you multiply 3 by 2, and that will give us 1. For this example, again, substitute logarithm of 2 times 5 plus logarithm of 5 squared plus 5 minus logarithm of 5 minus 2. Now let's simplify this. Logarithm of 10 plus logarithm of 25 plus 5 is 30 minus logarithm of 3. Now you notice that all of them have the same basis. That means that we can apply the limits of laws. Notice that the first two are connected with addition, so we can apply the first law of logarithms, which is the addition law, meaning we can combine the two by multiplying them. So let's multiply 10 by 30, and that will give us 300, or logarithm of 300. And then we have minus logarithm of 3. For this, since the two are connected with subtraction, we can apply the second law of logarithm, which is the subtraction law. We can combine the two logarithms by dividing their arguments, and that will give us 100. So we knew that the base here is 10. So 10 raised to 2 will give us 100.